Alright, so in this video we are going to take a look at solving some one-step equations. So when we do this, our problem is going to look something similar to this setup. So first we're going to want to solve and get the value for the variable, like in this case it's x, and then we're going to want to take that value and then just plug it back in to see if it gives us a true equality. So let's see, so our goal is to find a solution that will balance the equation, which we'll look at in a second. And the way that we do that is by isolating the variable. So we need to isolate the variable, which just means get it by itself, and we're going to do that by using inverse operations. So a lot of different vocab there, but let's just jump in with an example. And it has to do with a scale. So really the big picture of all of these problems is that you need to have a balanced scale. So you know on the right side of the scale there are 10 number cubes, and then on the left side there are 6. So your goal is to think, well, how many more would I need to add to make this true? That would be the solution. Well, with this one, it's pretty obvious to see that this x would have to be 4, right? Because if we put 4 in for x, 4 plus 6 definitely equals 10. So we know that that is a true statement. But what we're going to do down here is start to look at some more complex examples that might not be easy to just visualize in our head. So if we look at our example 1, so x minus 14 equals negative 5. So first of all, the x is what we're trying to figure out. We need to know what the value of that is. But right now, it's attached to a minus 14. So the way we isolate it, there's that vocab term again, is by using inverse operations. So we need to do the opposite of subtract 14, which is just going to be plus 14. But again, big picture, this is all a scale. It's a balanced equation. Right now, when we add that 14, it's no longer balanced. We need to add 14 to the right side as well to keep everything even. The nice thing, though, when we do that is, well, minus 14 and plus 14 will actually go away. So we can just cross them out. And then all that we have left over on the left side of our equal sign is just the x. And on the right side, negative 5 plus 14 gives us a positive 9. So our next step, we've solved it. We know the value is x. We used our inverse operation and we said we think we have the correct solution. The next thing we need to do is just plug it back in. So we know our equation is x minus 14 equals negative 5. So if we substitute or plug in 9 for x, again, you want to make sure anytime you plug something in, keep it inside parentheses. So 9 minus 14, does that equal negative 5? If you punch that into your calculator, it sure does give you negative 5. So we know that we found the correct solution, and we've checked it, and we're good to go. So what we want you to do is pause this video, use the left side, the example 1, as a model, and see if you can tackle this you try. Again, think about some inverse operations, remembering that your goal is to get x by itself, and remember to keep your equation balanced. Alright, so let's take a look. So if you did it correctly, I was getting x equals negative 9. So again, let's take that, what we think to be true, and plug it in. Let's substitute it in to see if it gives us a true equality. So let's see, our goal is to figure out, does negative 9 plus 8 equal negative 1? If you punch that in your calculator, it definitely equals negative 1. So we can give ourselves a check mark. We know that x equals negative 9 has to be the right solution. So these two examples, what we just did, involved adding and subtracting. So what we're going to do in example 2 is now introduce a little bit of multiplying. We said anytime we have a number, right, called a coefficient, in front of a variable, it's technically a multiplication problem. This is technically 1/2 times x. Again, our goal is to get this x alone. Right now it's tied in, it's attached to that 1/2 through multiplication. So all we need to do to get rid of that is just do the opposite or the inverse. So we're going to divide by 1/2. But again, if we do that on this side, we need to also do it on this side. So we're going to divide both sides of the equation by 1/2. If we do that, again, the 1/2 and the divided by 1/2 will cancel out and just leave us an x equals -14 divided by 1/2 should give us a -28. You can verify that on your calculators. The reason it becomes a bigger number, it's because of keep, change, flip. So if you're remembering from last unit, that's why. So again, our equation is 1/2 x equals -14. If we take our value of -28 and substitute it back in, so 1/2 times -28, does that equal -14? And if you punch that into your calculator, it definitely will give you a -14. So we know that we found the correct solution. And you can use your check boxes on the bottom if you want. We did our inverse operation of dividing. We wrote our correct solution, and then we checked it to make sure it was true. All right, so to wrap up everything, we have one more U try. Again, here's our x that we want to get by itself. And when it has a number in the denominator, right, this is technically like divided by 3. So of course, when we go to do the inverse, we're probably going to need to multiply by 3. And again, the other thing, this negative sign out front, remember from Unit 2, we said it can be out front, it can be with the numerator or with the denominator. So to make it a little bit easier on ourselves, I'm going to cover this one up, and I'm going to rewrite the negative with the 3, like that. Again, that is the same thing. And again, it's divided by -3. So pause this video, try to see if you can figure out what the inverse would be to get your solution. Okay, so the inverse of dividing by -3 would be multiplying by -3. So if we do that, it leaves us with just an x on the left side. -9 times -3 should give us a +27. So let's see, let's go back to our original equation. We're going to substitute 27 in. So it becomes 27. So -27 over 3 should equal a -9. This in your calculator definitely gives you a -9. So you know your solution that we thought x equals 27 was definitely going to be true. So we can use our check boxes and we are all done. So again, really big picture is making sure that you keep everything balanced and then also going back to check your solution. So hopefully this video helped. And in our next lesson, we're going to start doing a little bit with two-step equations. So looking forward to that.